This is Ham College, episode 105, for September 29th, 2023. Ham College is brought to you by ICOM. Keep your competitive contesting edge with ICOM. ICOM's high-power base stations cut through pileups, letting you work the bands and record those contacts. Contest from the comfort of your home or remotely with the RSBA1 app. Heard it, worked it, logged it. Good evening. Welcome to another episode of Ham College. I'm Professor Thomas.
And I'm Dean Martin.
And we've got questions.
Do we have answers?
Yes.
Do we have right answers?
Mostly.
Mostly. Maybe.
Yep.
It's a little bit early to tell for sure.
What did we talk about in the last episode?
Well, I just so happen to remember that pretty well, like it was a month ago. We talked about keying defects and overmodulation of digital signals, digital codes, and spread spectrum.
This month, we're going to talk about basic antenna parameters, radiation resistance, gain, beam width, efficiency, and effective radiated power. So, we're studying for the AmateurLogicExtra exam.
That sounds like some pretty good topics.
It is. You know, we do tend to use antennas in this hobby.
We have been known to use one or two.
So with that, I think maybe last time I took the first question. Do you want to take the first one tonight?
Yeah, go ahead and hit me with it. Let's get it over with. Like ripping off a Band-Aid.
Yeah. Well, oh, by the way, we've got a chat room going whenever we're streaming live. You can go, well, we're streaming on YouTube, so if you use the YouTube chat there, you can see what everybody's saying. If you want to contribute in there, though, you do have to subscribe to the AmateurLogic.TV YouTube channel.
Yeah. I think you have to be subscribed for like 5 minutes or something like that before it'll allow you to type in the chat, though. But just hang in there.
Yeah. So, yeah, we'd like you to subscribe anyway, but that's not why we put it there. That's just, to help us keep the spam and stuff out. So, but do click the subscribe button there and the like button while you're at it. That's both good things.
Yeah, can't go wrong with either one of those.
What is an isotropic antenna? A grounded antenna used to measure earth conductivity.
B, a horizontally polarized antenna used to compare Yagi antennas.
C, a theoretical omnidirectional antenna used as a reference for antenna gain.
Or D, a spacecraft antenna used to direct signals towards Earth. I'd like to think D is the most interesting out of those, but I don't think that that's the answer.
No.
But it's interesting.
It sounds,
It sounds pretty cool. Okay, but I actually know what this one is because I'm going to be honest with you on this one. I actually looked up the isotropic antenna.
Oh, you're just that kind of guy.
I did. So I know it's C. Theoretical omnidirectional antenna used as a reference for antenna gain.
I'm going to agree with you, and everybody over in the chat room does as well.
Yeah, I thought I had an idea what it was, but anyway, the rest of the questions I have not studied, so I have no idea. I read over them, I saw that, and I'm like, I thought I knew what it was.
Would you like a little explaining to go with that?
Yeah, that'd be great.
I think if we hypnotize the audience, an isotropic antenna is a hypotheoretical antenna radiating the same intensity of radio waves in all directions. It's said to have a directivity of 0 dBi relative to isotropic in all directions, even though an exactly isotropic antenna cannot exist in practice. It's used as a base of comparison to calculate the directivity of actual antennas. Yeah, you back with us?
Yeah.
On the left-hand side, the isotropic antenna is that little dot sitting right there in the middle of that sphere. We say that it's radiating equally in all directions, although it's not really possible, but for comparison examples, it's good. Now look over on the other side there, on the right-hand side, that's sort of what the radiation pattern would look like on a perfect half-wave dipole antenna. And notice that half-wave dipole is about 2.15 dB higher gain than an isotropic. And I'm guessing the reason for that would be the isotropic is basically a ball, and the half-wave dipole looks more like a slinky in a circle, but the top and bottom...
You don't have so much going out the top and bottom.
Yeah, it's kind of squashed down a little bit, so that would give it a little more gain. I did not look that up, so I don't know that that's a real thing there. So maybe I shouldn't have said it. But anyway, it seems plausible.
No take-backs now.
Well, too late for that now, yeah.
What is the effective... Oh, I'm glad this one's for you, too. What is the effective radiated power relative to a dipole of a repeater station with 150 watts transmitter power output, 2 dB of feed line loss, 2.2 dB duplexer loss, and 7 dB of antenna gain? A, 1,977 watts.
B, 78.7 watts.
C, 420 watts.
Or D, 286 watts. What was the effective radiated power relative to a dipole of a repeater with 150 watts transmitter power, 2 dB feed line loss, 2.2 dB duplexer loss, 7 dBd antenna gain? The way I would solve this, first thing I want to do is combine my losses. So 2 dB and 2.2 dB, that's 4.2 dB of loss. That's going to be for the whole system. That's, we've got details on there. 7 dBd antenna gain. So we're going to subtract 4.2 from 7 dB. That's going to give us 2.8 dB gain. We know we got 150 watts, and we got a little gain, 2.8 dB. That's almost 3 dB a gain. Would you concur?
Mm-hmm.
And 3 dB a gain
Just double your power.
is doubling your power.
So that would be D.
We know it's going to be a little more than 300 watts then. The closest answer we've got there I'm going to say C. I'm going to be wrong too if I say that. What am I
Double
missing?
your gain is 300 watts, and this.
Oh,
no, it's D. It's definitely D.
I'm going over. It's a little under 300 watts,
Uh huh.
not a little more. So, so it's got to be D then.
Yep.
So I don't know whether I get a buzzer on that or not, but it is. I miscalculated up here, and that can happen. I know you never had that issue, but
I try not to calculate anything up there, so I try to avoid that
as much as possible. Yeah,
it's tricky.
Yeah, I got a chart here.
Okay.
That might be handy at this point to look at. This is comparing dB to power ratios. If you look in the middle of the chart there, you see 0 dB is a power ratio of 1. So that would mean 1 times whatever the power is. Your power doesn't change. It's still whatever it is. If you go up 1 dB, that's like increasing the power of 1.295. Almost 1.3. If you go to 3 dB, that's almost a 2 times power gain. It's 1.995. 6 dB is about double that, 3.981. 10 dB gain, we're going to multiply whatever our power is by 10. And then 20 dB gain, you would think maybe that would be times 20, but no, that's times 100.
Wow.
Because once you get to 10, to add another 10, you may remember we talked about this a long time ago. You say 10 times 10. to add that second 10 dB of gain. So that's 100 power ratio. If you go in the opposite direction, if we're going down -1, that's like a little over 0.75 or 3/4. -3, that's about multiplying by a half, by 0.5. 10 is 0.1 down at the bottom there. 20 is, 0.01. So you got that in mind? This might come in handy a little later.
You think it might?
I think it could.
Yeah. I thought about writing it down, but you can't write them down in the test. So,
What is the radiation resistance of an antenna? A, the combined losses of the antenna elements and feed line.
B, the specific impedance of the antenna.
C, the value of a resistance that would dissipate the same amount of power as that radiated from an antenna.
Or D, the resistance in the atmosphere that an antenna must overcome to be able to radiate a signal. What is the radiation resistance of an antenna? Combined losses of the antenna elements and the feed line. Specific impedance of the antenna. Or the value of a resistance that would dissipate the same amount of power. I'm gonna guess to go with C. I think it's either C or A, but I'm pretty sure it's gonna be C. What's the chat?
Okay.
Chat room
saying C. I'm thinking C. And it is.
C. Senor.
Mm-hmm. All right.
I think I might be broke out of sweat on that one.
Well, that's not going to work out too good in here because the air conditioner's off now. And it's still a little warm down here.
Yeah, it's better though.
Yeah.
All right, got one for you. Which of the following factors affect the feed point impedance of an antenna? A, the transmission line length.
B, antenna height.
C, the settings of an antenna tuner at the transmitter.
Or D, the input power level. Which of the following factors affect the feed point impedance of an antenna? Well, let's go through them all. First, A, transmission line length. No, because the transmission line is going to have the same impedance whether it's a foot long or whether it's 100 feet long. If it's 50 ohm lines, it's going to remain 50 ohms. D, the input power level. The amount of power is not going to affect the impedance of the antenna. C, the setting of an antenna tuner at the transmitter. No, because we're talking about the impedance not at the transmitter, but at the
That's just going to make the radio appear to be matched.
Yeah, right at the input of the antenna. So, and we all know that the antenna length, in this case, the antenna height, does have an effect on or the wavelength of it. It will affect the impedance. So, yeah, I'm going to say it's antenna height. Everybody in the chat room saying that.
Yeah, I think that's right, too.
And it is.
I think that's one reason why it's important to get it half wavelength above the ground or whatever.
Yeah, well, but yeah, but that's not what they're exactly talking about. What they're talking about is if you cut an antenna for a quarter wavelength and put it out there, it's it's going to be a certain impedance.
Mm-hmm.
Right about what we're targeting at. But if you cut it at say a little over or a little under that, the impedance changes. Your SWR is not the same.
Mm-hmm.
So, or like on a half-wave dipole, they got to be the right length.
Yeah, they got to be right length to match for the frequency. But it says height. Antenna height.
But that's how much you chop off of it is what they mean, I think.
Okay.
Yeah, it's they didn't say a vertical antenna. But yeah, the antenna height how high it is off the ground would affect that too. That's a little That's a little vague there, actually, if you think about it. I wish they had said a vertical antenna, but they didn't. So yeah, it could go either way.
But just know it's antenna height is what
Yeah.
the answer is for that one.
Yeah.
So
See, Tom says a half-wave resonant dipole in free space is 73.42 ohms. When center fed, drops down to 50 ohms near 1/2 lambda off the ground. So there you go. What is included in the total resistance of an antenna system? A, radiation resistance plus base impedance.
B, radiation resistance plus transmission resistance.
C, transmission line resistance plus radiation resistance.
Or D, radiation resistance plus loss resistance. So this one's worded a little different. What is included in the total resistance of an antenna system, not just the antenna? So A, radiation resistance plus space impedance? No. B, radiation resistance plus transmission resistance? That sounds plausible. C, transmission line resistance plus radiation resistance would be the total resistance of the antenna system.
See, over in the chat room,
Well, we got
they're a little
some
mixed.
mixed.
Yep. And I'm going to be honest, I had to,
I think it's,
I typed these
I don't
questions
know for
in.
Sure.
So I have to go over these.
Uh-huh.
I usually do it, sometimes it might be the day before, but usually a week or two ahead of time. And my first time around, that's the answer I picked.
See?
C. Unfortunately, it was the wrong answer.
Okay. Well, it's bound to happen sooner or later.
If we look at C and D, yeah, transmission line resistance, there is a little resistance in the transmission line. And then you would say plus the radiation resistance. Well, you would think that's it.
I clearly did.
But radiation resistance plus loss resistance, which to me, transmission line resistance would be a loss resistance. But there's other loss resistances as well. Like if, say your antenna's sitting out here and you got a tree sitting over here, there's going to be some loss caused by that tree. It's going to soak up a little of that power. It's not going to get irradiated out.
I got that going on at the house.
I do too.
Yeah.
Same thing here. So anyway, loss can mean a lot of different things.
It says the antenna system.
Yeah.
But I guess the environment counts in that.
It does, because if it's by the antenna, it's affecting the performance of the antenna system.
Well, I never thought about taking the environment into account. Which I understand what you're saying about trees and other things like that.
When I said C in my head when I was first going over these, I had not considered that. But that is one of the possible losses.
Interesting.
Yeah.
Not good for me, but it's interesting.
It is, nonetheless. And you took one for the team on that one.
You're welcome.
But you weren't the only one. There were other people.
That was in good company.
Yeah.
All right, here's one back at you. What is the effective radiated power relative to a dipole of a repeater station with 200 watts transmitter power output? 4 dB feed line loss, 3.2 dB duplexer loss, 0.8 dB circulator loss, and 10 dB of antenna gain.
10 dBd.
10 dBd of antenna gain. A, 317 watts.
B, 2,000 watts.
C, 126 watts.
Or D, 300 watts. What is the effective radiated power relative to a dipole of a repeater station with 200 watts transmitter output power, or transmitter power output, same difference. 4 dB of feed line loss. I've got 4 dB of loss. I've got duplexer loss of 3.2 dB.
7.2.
I've got
0.8 of circulator loss.
0.8
So
of
that's
circulator
8.
loss. Yep. So
And then 10 dB.
that's, if you add all those together, you've got 8 dB of loss.
Mm-hmm.
Okay. And our gain, we've got 10 minus 8, we got 2 dB of gain. Because we are talking about a dipole antenna.
Yep.
And dBd means decibels relative to a dipole. 2 dB of gain, that is, it's going to be just a little over 1.5. I'm going to say a 317 watts. And it is. And let me check, because I actually have it written down here. 2 dB of gain is 1.58 power ratio, so we'd multiply 1.58 times 200. What do you say we take a break?
Give away something?
I think we'll probably give away some wardrobe, because I see there's some folks out there that could use
an upgrade.
Yeah. People would say that about us too, I'm sure. But
no, this thing. This
no,
is
not
VE3MIC.
Yeah.
Mr. and Mrs. VE3MIC shirt special. It's a pretty cool shirt.
Yeah, we better take a break.
Keep your competitive contesting edge with ICOM. ICOM's high-power base stations cut through pileups, letting you work the bands and record those contacts. Contest from the comfort of your home or remotely with the RSBA1 app. Heard it, worked it, logged it. The IC7851 gives you a new window into the RF world and is HF excellence unparalleled. With faster processors, higher input gain, higher display resolution, and a cleaner signal, it's truly the pinnacle of HF perfection. Dual receivers, digital IF filters, memory keyer, digital voice recorder, high-resolution spectrum waterfall display, enhanced PC connectivity, and SD memory card slot. The IC7610 is the SDR every ham wants. This high-performance SDR can pick out faint signals in the presence of stronger adjacent signals. The ICOM IC7610 is a direct sampling, software-defined radio that has changed the world's definition of an SDR. RF direct sampling system, 110 dB RMDR, independent dual receivers, and dual digicell. ICOM's IC7300 is a high-performance, innovative HF transceiver with a compact design that will far exceed your expectations. This innovative HF transceiver digitizes RF before various receiver stages, reducing the generated inherent noise in different IF stages. This is a radio that changed the way entry-level HF is designed. RF direct sampling, 15 discrete bandpass filters, large 4.3-inch color touchscreen, real-time spectrum scope, and SD memory card slot. The real HF fun starts here. For more information about ICOM's amateur offerings, visit icomamerica.com/lineup/amateur.
What do you say we give away something?
I just so happen to have something right here. How about this?
A Ham Crew t-shirt.
ICOM Ham Crew t-shirt, compliments of ICOM. And, yep. How are we going to give it away?
We're going to do a drawing for a set of emails that we received. People send emails to hamcollege at AmateurLogic.TV. They're all registered to win a nice swag package from ICOM, including a t-shirt and whatever else Jesse stuffs in the
Hey,
box.
if they sent one this month, are they good for next month too?
No. They've got to send a new one every month, because we delete the emails after each month drawing.
So after this show, actually probably now.
Yeah, right before the show, I deleted all after we chose a winner here. And the lucky winner in the chat room.
Oh, cool. Oh, I'll see that from here. Awesome.
I really enjoy Ham College, particularly since they've added so many subjects to the test, and they have.
Yeah.
Tom Freerich, I guess that's how you pronounce your last name, Tom. You'll have to tell me if I'm wrong. AE0GQ.
So you'll be looking good at the Hamfest, next Hamfest, Tom, and when you leave, you'll be looking just as good.
What is the effective isotropic radiated power of a repeater station with 200 watts transmitter power output, 2 dB feedline loss, 2.8 dB duplexer loss, 1.2 dB circulator loss, and 7 dBi antenna gain. Is it A, 159 watts?
B, 252 watts.
C, 632 watts?
Or D, 63.2 watts. Okay, so let's see here. Let me put my thinking cap on. My Gazinta's going on. 200 watts transmitter power, 2 dB of feedline loss, 2.8, 4.8, plus 1.2, that's 5, 6 dB, and a 7 dB antenna gain. So that's 1 dB. So instead of doubling it, 1 dB. So I'm going to go with B, 252 watts.
Okay. Chat room, B's, a D. I'm going to go with you. Going to be a little better than 200 watts.
Yeah, a
But
little
I
bit,
don't
but
think
not-
it's
not-
going to be 632.
No, it's got to be B. I don't see how it could be anything else.
Okay. Totally redeemed yourself.
I'm gonna have to get one of those for that. I had to do math tonight.
Yeah.
What is antenna bandwidth? A, antenna length divided by the number of elements.
B, the frequency range over which an antenna satisfies a performance requirement.
C, the angle between the half power radiation points.
Or D, the angle formed between two imaginary lines drawn through the element ends.
They got quite
yeah.
creative on this
Yeah,
one.
I don't think it's D. What is antenna bandwidth? Antenna length divided by the number of elements. No, that's not it. C, the angle between the two half power radiation points. No, it's B, the frequency range over which an antenna satisfies a performance requirement. Looking in the chat room, everybody's saying it's B, so I feel good about that answer.
Yep. Yeah, that was pretty straightforward.
Yeah.
By the time you've been a ham long enough to want to take your extra, you probably know that one. That's almost a freebie there. Freebie.
Yeah.
See what I did there? A freebie.
I do see what you did there. Let's see. It was. Yep, it was B. All right, let's see. Well, no, I don't have another math one for you, but I got this. What is antenna efficiency? A, radiation resistance divided by transmission resistance.
B, radiation resistance divided by total resistance.
C, total resistance divided by radiation resistance.
Or D, effective radiated power divided by transmitter output. Antenna efficiency. I'm going to have to think about this one because I don't know, like, right off the top of my head. Radiation resistance divided by transmission resistance. Radiation resistance by total resistance. Total resistance divided by... I'm going to go with D. It may be wrong, but I'm not sure.
And you would think it's D,
Obviously.
but it's not. It's B.
Well, I said B.
No, that's not what you said.
B and D kind of sound similar.
That's not what I heard.
Okay.
Yeah.
So the word resistance kind of messed me up in there.
Mm-hmm. Yeah, I really didn't do any study as to why that is the answer there. But I happen to have Gordon West
Book of
Extra
Intelligence.
Antenna. Book of
Heck
Gordo. The efficiency of your antenna is an important consideration when you plan to upgrade your antenna system. Yes, I would say so. Efficiency equals the radiation resistance divided by the total resistance. You want to keep your total ohmic resistance as low as possible to make your antenna more efficient. Generally, bigger antenna elements have greater radiation resistance, lower ohmic resistance, higher efficiency, and increased bandwidth. Bigger is always better. Answer B. Well, thanks for that, Gordo.
Yeah.
That's a good explanation there.
I'll say so. Which of the following improves the efficiency of a ground-mounted quarter-wave vertical antenna? A. Installing a radial system.
B. Isolating the coax shield from ground.
C. Shortening the radiating element.
D. All of these choices are correct.
I think I know this one.
All right. Which of the following improves the efficiency of a ground-mounted quarter-wave vertical antenna? Well, it's not all these choices, so we can strike out D. Shortening the radiated element. No, if it's a quarter wave and you shorten it, that's not going to help anything. It's going to make it worse. Isolating the coax shield from ground. No, it would probably be good if your coax shield was at ground. If it's a ground-mounted quarter wave vertical antenna, you got to have a radial system. So, A, install a radial system. You concur?
I do concur.
Chat room concurs.
We actually discussed something about this on the way over here, when I was on the way over here. Not this question,
Well, we did.
but something else that I'm planning on doing for a
Yeah.
segment.
Which of the following factors determines ground losses for a ground-mounted vertical antenna operating in the 3 megahertz to 30 megahertz range? A. Standing wave ratio.
B. Distance from the transmitter.
C. Soil conductivity.
Or D. Takeoff angle. Which of the following factors determine ground losses? Ground losses for a ground-mounted vertical antenna operating 3 megahertz HF band. Ground losses. I don't think it's A. B. Ground losses. No, not B. C. Soil conductivity's got to be the one. Ground loss. Or takeoff angle. I think it's going to be C.
The one thing I'm unclear about, why they worded it this way, operating in the 3 megahertz to 30 megahertz range, ground losses are even a factor down on the AM broadcast band, down, as low as 500 kilohertz.
Yeah.
Because the FCC has published standards for ground losses when you're applying for an AM broadcast license. So it's got effect below 3 megahertz.
Yeah, but these are people that are taking the test for AmateurExtra.
Well,
So-
what I'm thinking, though, is it would have an effect at 160 meters, too.
Yeah.
So,
Oh, yeah.
yeah. So I'm not sure why they limited it at 3 megahertz on the bottom end, but they did.
Probably just to be some trickery.
Yep.
All right, we still got any more?
I think we do.
We ought to be getting pretty close to the end, although we did have a few more this time than we normally do.
I think we got a couple more left.
Okay, good. How much gain does an antenna have compared to a half wavelength dipole when it has 6 dB gain over an isotropic antenna? A, 3.85 dB.
B, 6 dB.
C, 8.15 dB.
Or D, 2.79 dB. How much gain does an antenna have compared to a half-wave dipole when it has 6 dB gain over an isotropic antenna? All right, if I've got an antenna that has 6 dB gain over an isotropic antenna, that would be 6 dB. But I happen to remember earlier, you remember when we were talking about the isotropic
Yeah,
radiator?
with the slinky.
Yep, and then we were talking about the half-wave dipole with Slinky. And the half-wave dipole has 2.15 dB gain over an isotropic.
Yeah.
So let's see. This antenna is going to have 2.15 dB less if we're comparing it to a dipole than an isotropic. So
roughly
that's going to make it 3.85. Yeah.
That makes sense.
3.85. Yeah, because we're comparing it to the dipole. All right. Chat room. They're kind of, yeah.
It makes sense if it's right.
Yeah.
Otherwise, I've totally lost.
Let's see.
Okay.
It is. All right. This time around, you know, each section that we study here, we generally got, they vary, but usually around 12 questions in each study group that we cover here. Tonight, however, it's not always 12. You're lucky 13.
It's the baker's dozen tonight.
It's a baker's dozen. And you're the lucky winner.
All right. Well, hit me then.
All right.
What do I win?
A question. What term describes station output taking into account all gains and losses? A, power factor.
B, half power bandwidth.
C, effective radiated power.
Or D, apparent power. What term describes station output when taking into account all gains and losses? Well, we've been discussing this all night. So I'm going to go with straight to C, effective radiated power.
I don't see how anybody could argue with that. Chat room certainly isn't.
I don't know. Some of them gave the answer ERP. There's not even an ERP up there.
Effective radiated power.
Yeah, but that's,
oh, I see where you're going. Yeah.
I was still trying for some of that wit, but I've completely failed.
Effective radiated power.
Yep.
All
That's
right.
it. We've been talking about it all night. It'd be pretty hard to miss that one, I think. Well, those are a good set of questions, even though I got buzzer, once or twice? Twice. I got buzzed twice.
Did you?
Yeah.
Well, it'll show up in the edited version, I'm sure.
I got buzzed twice, trust me.
Okay. I maybe got buzzed one time there because
if you didn't,
I
you
caught
probably
myself,
deserved
but
one.
I probably I'll take at least half of one.
Okay.
I may deserve a whole buzzard.
All right.
Yeah, these you just got to think about a little bit. Maybe study your decibel chart before you go take the exam. Might be a handy idea. And remember the difference between DBD and DBI. We're talking about decibels compared to a dipole or to an isotropic antenna.
And thanks, Marty. He said he laughed at my horrible joke. I figured somebody would feel bad for me and laugh. So thank you, Marty.
Yep.
What's all this stuff we got sitting all around the table here?
You know, we do have a lot of stuff sitting here. We're going to have to clear this out of the way. There's just not enough room for all the papers we got. You know, AmateurLogic's coming up on 18 years.
Wow.
In
18 years of funness.
In October, which is next month. 18 years.
Wow.
That's a long.
And I say it every year, but I promise you, I remember like it was yesterday, sitting in that other building against that wall over there, recording that other one.
Mm-hmm.
And I left here to go home and got pulled over by the police.
That should have been a sign right there.
It was after the hurricane and like the traffic wasn't out so much.
Oh yeah, because we shot the outdoor footage while the hurricane was approaching. You could see the trees and all. But yeah, we didn't shoot the wrap up until like almost
Yeah, they must have had some kind of curfew or something. But I got pulled over right there by where that little car lot is.
Yeah.
Right beside there for a minute. He was wondering what I was doing out.
Well, we must have had electricity, or we couldn't have been
Yeah,
recording.
we had electricity. I
Yeah.
don't know. Maybe it was a curfew. I don't know. I don't remember, but I remember I got pulled over. He
Yeah.
asked me what I was doing and just went home.
To celebrate doing this for 18 years, we're going to give away a prize package here, thanks to our good friends and sponsors at ICOM and our friends at MFJ. An ICOM IC705 transceiver,
MFJ 4230 MVP power supply.
an MFJ 1982 LP infed antenna,
We've got 25 feet of MFJ RG8X coax.
and MFJ 915 RF line oscillator,
And last but not least, we've got an MFJ wood keyer. Base
553.
553. You changed the
Yeah,
screen on me while I was
I
reading
did.
it. So
Well, let's talk about this IC705 base station performance and features in the palm of your hand, designed for field operations. The IC705 is packaged in a compact and lightweight portable size. Whether you're taking your hobby to SOTA, POTA, or some other on-air location, the IC705 will be your go-to rig. Multiple modes on HF, 50 megahertz, 144, and 440 megahertz. You can enjoy a variety of bands and modes: D-Star, DV, single sideband, CW, RIDI, AM, and FM modes, as well as, FT8 mode. Now, the IC705 receives continuously from 30 kilohertz to 440 megahertz. And you can enjoy FM broadcast band and airband reception as well.
the IC705 employs an RF direct sampling system where RF signals are directly converted to digital data, then processed in the FPGA or the field programmable gate array, making it possible to simplify the circuit construction as well as reducing internal noise that can mask weak signals. You can quickly see band activity as well as find a clear frequency. Scroll mode automatically keeps the operating signal within the scope range.
It's got a large color touchscreen display, 4.3-inch TFT, same size as the IC7300 and IC9700. You got intuitive operation of function settings, various operational visual aids such as band scope, waterfall, audio scope functions, a one-touch FT8 mode preset in there. It gives you smoother operation of FT8 modes. You can start FT8 mode by selecting FT8 from the preset menu, and you got up to 5 preset memories that can be stored.
Base station performance in the palm of your hand. You'll quickly see how this compact radio is rugged for outdoor use in a small, lightweight package weighing approximately 2.4 pounds. Utilizing the high-capacity lithium-ion battery from the ID51A and the ID31A handheld radios. A 13.8-volt DC external power supply can be used for operation and charging of the BP272.
And that's what we're doing right now. We got 13.8 volts.
Yeah, because
plugged
half
into
of
this
us up here didn't charge the radio up.
Yeah. Maximum output power is 5 watts with the battery pack 272, or 10 watts with 13.8 volts DC. So with the battery pack, you can get approximately 3 hours. That's perfect for true 5-watt QRP operation, as well as 0.5 watts QRPP operations. Once you set up with 13.8 volts DC power, you'll have up to 10 watts, which is what you did at field day, wasn't it?
It was.
Yeah.
WLAN or wireless LAN/Bluetooth technologies for linking the remote control for a true wireless operation. The VS3 headset is optional. It enables more comfortable operation via Bluetooth. And I worked Bluetooth the headset all field day the whole time.
You did. It's got GPS functions, internal GPS receiver and antenna, enhance your operations by providing location logging, RxTX locations by DPRS, near me repeater search scan, QSO recording with metadata, and internal clock synchronization. It's got a micro SD card slot too that you can use to store user profiles, QSO recording, transmit voice memory keyer, ready logging, GPS data, screen capture, firmware upgrades, and programming.
It's got a micro USB connector in addition to the 2 COM ports, a radio control plus audio. The IC705 can be charged via the micro USB port, which is very handy. It's got D-Star functions. Enjoy the latest DV mode features with the IC705. Have direct access to D-Star network with terminal access point modes. Additionally, the IC705 has a photo share feature introduced with the IC9700. Share photos without the need of a computer with other users with an IC705 and 9700 and the ID52 now.
And enjoy portable operations with the supplied HM243 programmable speaker microphone, as our hand model is demonstrating. Perfect for operation with the IC705, secured in the optional LC192 backpack. User assignable buttons, plus functions like frequency and volume adjustment at the tips of your fingers without removing your backpack. And the optional backpack LC192 is ideal for field operations, designed to be the ultimate must-have accessory for the IC705. The LC192 is a perfect utility backpack. Features a safety strap with a 1/4-20 mounting lug to keep your IC705 from accidentally falling out of the custom radio compartment. It's got user and adjustable panels inside as well for custom compartments for antennas, battery packs, or other items necessary for an afternoon soda activation. So an IC705, we're going to give away Tommy's radio.
No, we're not.
On the next episode of Amateur
We'll
Logic.
give one like mine.
Like yours, okay. You're going to need an antenna for that too, so we've got, what is this? This is an MFJ 1982 LP end-fed half-wave antenna. It's 30-watt end-fed antenna, full HF coverage from 80 meters to 10 meters. No tuner needed on most frequencies. No long counterpoise or radials or feed point required, although you do need to use a short radio with it. Rugged, weatherproof construction, 50 ohm matching network, fast setup and teardown, easy storage and transportation, and it's got stainless steel hardware. A UV resistant material throughout. Broadband matching. You can get on the air just one high center or end support. Installation is fast for home, road, or emergencies. You can install it virtually anywhere in minutes. Comes with a rugged insulated wire radiator that prevents detuning when contacting limbs or branches. No snag end insulator, slides over branches and through foliage without hanging up. You can toss it over a limb for an inverted V, raise the far end high for a powerful sloper, or even go vertical with an inverted L. Dark jacketed wire is virtually invisible, so you don't let antenna restrictions keep you off the air. The end-fed half-wave antenna makes a great emergency backup for your regular antenna. And we've also got an MFJ 1915 RF isolator.
This 1-to-1 current balun designed to be placed in line with a 50 ohm coax. The RF isolator is effective from 1.8 to 30 megahertz. It was designed to improve the performance of all amateur stations, fixed or mobile. The MFJ 915 will reduce or eliminate stray RF often found on coax. This stray RF can cause burns and other problems with electronic equipment in ham shacks and vehicles. Stray RF also results in a loss of radiated power from the antenna, which will lead to a great reduction in signal strength. Use of the MFJ 915 will increase the efficiency of all amateur stations. It's made up of 50 ferrite core beads placed into a 13-inch piece of RG303 coax. The coax and SO239 connectors have Teflon for maximum insulation and extended life of the product.
We've also got an MFJ 4230 MVP compact switching power supply. This is the same power supply that Dean Martin uses at his home station.
Yep.
I've got a version of that as well. It's a 30 amp Mighty Light switching power supply with all the popular features. It's got a Anderson power poles here in the rear. It's got a 5-way binding post that allow easy access to connections for your rig or station accessories. 25 amps continuous, 30 amp surge at 13.8 volts DC, adjustable from 4 to 16 volts, and you can choose 120 or 240 volts at 47 to 63 hertz, so you can take it anywhere here in the U.S. and abroad. You could even take it to Canada.
Yep. We also have the MFJ 533 Deluxe wood-based telegraph. Features a Morse code straight key on a non-skid, beautifully stained wood base. It has a steel base under the bottom so it stays put on the table and doesn't move around while you're sending. Hook up the straight key to your transmitter and go on the air sounding like you were born working QSOs and looking good doing it. The pre-wired plug is a stereo plug wired for tip and sleeve connections for those radios that require the use of a stereo plug. Of course, it works to radios that require mono connections, whereas the ring on the plug is not connected.
All right.
And that'll plug right into the side of that radio right there.
And one final item that you're going to want with all this, MFJ 5825X coaxial patch cable. This is a 25 foot of pre-made premium coax, weather resistant 50 ohm RG8X coax with pre-soldered PL259 connectors.
They're not faux gold either.
Nope, they're not faux gold. They're
better.
real metal.
They're better, yeah.
Yes. AmateurLogic.TV/contest. Go there. You can get a rundown of the prizes as well as the information you need to enter the contest. You got to be qualified, first of all. You got to be a licensed U.S. or Canadian amateur radio operator with a U.S. or Canadian shipping address.
Only one entry per contestant, please. Sending more than one entry disqualifies the applicant.
The winner is responsible for any taxes that are incurred.
The winner agrees to the use of his or her call sign and name in promotional and news items related to the contest.
And contestants must not be an employee or affiliate of AmateurLogic, ICOM, or MFJ Enterprises. How to enter? Well, send us an email to contest2023@AmateurLogic.TV. And this is important, only your call sign in the subject line. Only your call sign. Include your name, call sign, class of license, and address in the email message.
Submissions must be made between Friday, September 15th, and Monday, October the 16th. So you've got a little over 2 weeks left to get your entry in.
We'll count how many entries we've got, generate a random number within that range. We'll be announcing the winner on the October 20th episode of AmateurLogic.TV. That gives you a little bit more time to enter. If it's determined that the winning entry does not meet the qualification requirements, another winner will be chosen by the same method. Contest rules and information will be posted at AmateurLogic.TV/contest. One final thing.
Void where prohibited. This is the site that he just gave you the address of as well. That's what we're looking at. So,
Yep.
have any questions, just go here. You should get an autoresponder when your submission is received. If you don't get it, check your spam folder, and before you send an extra one, check with one of us, or George or myself can check and make sure we got your entry before you send one and get disqualified. So
Yeah. Just drop us an email. We'll be happy to check it for you if you don't get the autoresponder. We've had quite a few entries already. I checked last night.
So.
Yeah. We got room for more, though. So if you haven't entered yet, by all means, if you're a U.S. or Canadian amateur operator with meets the requirements there, go enter right now, if you haven't already. If you have, don't enter again to avoid disqualification.
Again, you probably heard me say it before. If I had to get rid of every radio I own and just keep one of them, this would be the one that I keep.
Well,
It's the most versatile.
it's pretty much a no-brainer because it's got everything.
Yeah, just doesn't have as much power, but I haven't had any problem making contacts out of it, especially with 10 watts.
But if you could only have one radio, it's got all the bands.
It covers everything I need.
Yep, and it's portable.
Yep.
So, great choice.
Great, yeah, definitely is.
And thanks again to ICOM for donating a great radio there, and MFJ for all the accessories here.
Yeah. So it's a really nice package. Somebody's going to enjoy it.
Yep.
I'm looking forward to seeing who the winner is.
So the next Amateur Logic is going to be October the 20th.
Yep.
I don't know what everybody's doing yet. We haven't really discussed it among ourselves, but Mike was out last episode. He'll be back on the 20th as well as email the cheap old man who was cheaping out in the chat room earlier.
I'm the slacker of the month.
You are the slacker of the month. That
Yep.
means I got to come up with a segment.
So that's actually 2 days before my 35th anniversary. So when we get off here, I'm probably going to leave and go out of town for a day or two.
Okay. Thanks for being here tonight, everyone. We appreciate everyone in the chat room watching live, and those of you who watch the download or YouTube video afterwards as well.
Yep. Well, I guess we're going to wrap it up. We'll see you guys on the 20th, hopefully, for the drawing.
Mm-hmm. And the next Amateur Logic, and we'll see you at the end of October for the next time college. Till then, do your studying. Pull out your reference material, whether it's a Gordo's book or ARRL materials. You want to do a little studying.
It's a pretty tough test. I'm not going to lie about it.
But it is passable, obviously.
Clearly.
Yeah.
Clearly.
7-3, everybody.
7-3, everybody.